Okay, we are going to do question 5 from November 2021. The question is on rate of reaction. Okay, let's see the question. So this is the question. It is on rate of reaction. Let me read the question. The reaction of 15 grams of an impure sample of calcium carbonate with excess hydrochloric acid of concentration 1 mole per cubic decimeter is used to investigate the rate of a reaction. The balanced equation for the reaction is, this is the balanced equation for the reaction. The volume of carbon dioxide gas produced is measured at regular interval. A sketch graph representing the total volume of carbon dioxide gas produced as a function of time is shown below. So you have the volume of carbon dioxide on the vertical axis and time on the horizontal axis. Question 5.1, define the term reaction rate. And the question is 2 marks. There are many definitions for reaction rate. Okay, I'm going to give you only 5 of them. I'm not going to waste time on explaining all of them. So the first definition can be this one. The rate of a reaction is the change in number of moles of reactant or product per unit time. Okay, I'm not going to waste time on explaining this. So you can read the definition, try to memorize it, try to understand it. The other one can be the rate of a reaction is the change in concentration of product or reactant per unit time. The other one can be the rate of reaction is the number of moles of product formed or the number of moles of reactant used per unit time. The other definition can be the rate of a reaction is the volume of product formed or the volume of reactant used per unit time. The other one can be the rate of a reaction is the mass of product formed or the mass of reactant used per unit time. So you have 5 definitions here. I think this is enough, but the question is asking you to only give one definition. Okay, you will give the definition that you are comfortable with whenever they ask you to give the definition of rate of reaction. Okay. Okay, the next question, let's see the question. It's from November 2021. So give a reason why the gradient of the graph decreases between T2 and T3. Between T2 and T3, why is the gradient decreasing? Why is the gradient of the graph decreasing between T2 and T3? Okay. So what can be the reason? The reason can be 5.2. The reason can be because the rate of the reaction is decreasing. This is why the gradient of the graph is decreasing. So we can say the rate of reaction or the reaction rate is decreasing. Or you can say the reactant are used up. So the reactant are used up. This is why the gradient of the graph is decreasing between T2 and T3. You can see, let me show you on the graph what is happening here. Can you see from T2 and T3, you can see the reaction is coming to completion. So after that, you have this horizontal line. It means that there is no more production of carbon dioxide. So the carbon dioxide gas is no more produced when you have this horizontal line. So this is why the gradient is decreasing from T2 to T3 as the reaction is coming to completion. The question is 1 mark. You just have to give one reason. You can give this one or this one. Okay, let's see now the next question, 5.3. Changes in the graph between T1 and T2 are due to temperature changes within the reaction mixture. 5.3.1 is the reaction exothermic or endothermic. So between T1 and T2, you can see between T1 and T2, the gradient is increasing. And for that, this will be exothermic. So you have 5.3 and 5.3.1. The reaction is exothermic because there is an increase in the gradient of the graph. Now 5.3.2, they say explain the answer by referring to the graph. The explanation can be the reaction rate is increasing. So we can say reaction rate increases, and you can also say the gradient increases. Gradient increases from T1 to T2. Energy is released. You know, when it is exothermic, the energy is released. So these three explanations are enough for you to score 3 marks. You can see the question is 3 marks. Okay. Now 5.4. Let me get the question. This is the question. Okay. So 5.4. The percentage purity of the sample is 82.5%. Calculate the value of X on the graph, assuming that the gas is collected at 25 degrees Celsius. Take the molar gas volume at 25 degrees Celsius as 24,000 cubic centimeter. This is supposed to be cubic centimeter per mole. I think this is a typing mistake. Okay, the units are cubic centimeter per mole. Now you need to find what X from the graph. What is X? X is the volume of carbon dioxide. Can you see the vertical axis is for volume and the horizontal axis is for time? So X will be the volume of carbon dioxide. At the end of the reaction, you can see you have the horizontal line. It means that there is no more production of carbon dioxide. The reaction has come to completion. Okay, you are going to need this balanced equation. Let's write it down, this one. Okay, so this is the balanced equation. And you are going to need this formula. N is equal to V over Vm. Vm is the molar gas volume. You can find this formula from the formula sheet, which will be given together with the question paper. You'll find this formula. And you'll need to find what X, which is the volume. So you're going to make V the subject of the formula. V is equal to N times Vm. Vm is the molar gas volume. Okay. And this Vm, the molar gas volume, is given. It is equal to 24,000 cubic centimeter per mole. It's given there. You can see. So what you need to find is the number of moles of carbon dioxide. Remember, you are calculating the volume of carbon dioxide. This is X. So what is the number of moles of carbon dioxide? You are going to calculate it. Can you see you are only given the mass of an impure sample of calcium carbonate, which is 15 grams. So you need to find what? The number of moles of calcium carbonate, not an impure calcium carbonate, but you need to find first the mass of calcium carbonate and convert it to mole. From there, you use stoichiometry to calculate the number of moles of carbon dioxide. Let's see that. So you have 15 grams of an impure calcium carbonate. And when you read the question, you can see the percentage purity of the sample is 82.5%. Can you see that? So 82.5% will be calcium carbonate. So not the whole 15 grams is calcium carbonate. 15 grams is for an impure sample of calcium carbonate. Impure means that you have some particles or some dirt which are not calcium carbonate. So for you to find the number of moles of calcium carbonate, you are going to use only the mass of calcium carbonate, not the impure calcium carbonate. Now let's find the mass of calcium carbonate only. So 82.5% is the mass of calcium carbonate. Let's find it. So you'll say 82.5, you divide by 100 times the 15, which is equal to, you need to find now the mass of calcium carbonate only, not the mass of an impure calcium carbonate, which is given 15 grams. Let's find the mass. We are going to use our calculator. So this is what we have, 82.5 over 100 times 15, and this is equal to 12.375. okay, 12.375 gram of what? Calcium carbonate. Okay, so in the 15 gram you add calcium carbonate plus some particles or some dirt which were not calcium carbonate. Using the percentage, you now find the mass of calcium carbonate only. So from here, you are going to find the number of moles of calcium carbonate. Now let's find what? The number of moles of calcium carbonate. So you are going to need this formula. The number of moles is equal to the mass over the molar mass. This is molar mass. The uppercase M is for molar mass. And you can find this formula on the formula sheet together with the question paper that you will be given. So what is now the number of moles of calcium carbonate? It will be equal to, you have this for mass over the molar mass. So now the molar mass will be calculated using the periodic table. So you should expect something like this. This is what you are going to get together with the question paper. And from here, you can now calculate the molar mass of calcium carbonate. So let's get the molar mass of what? Calcium carbonate. So you are going to use the atomic mass of the atoms in the compound to calculate the molar mass. So what is the atomic mass of calcium? You can see there is calcium, you have 40. Can you see? This is the atomic mass. Can you see atomic mass? You use the value at the bottom. So for calcium, you have 40. So it will be 40 plus, now you have carbon. Can you see? This is carbon. So you have calcium, carbon, and oxygen. 40 for calcium, and then now it's plus. Now the carbon one is 12. So the atomic mass for carbon is 12. It will be plus 12 plus. Now you have 3 atoms of oxygen. Can you see that? And for oxygen, what is the atomic mass? It's 16. Can you see? 16. Okay. Let me close this. So it will be plus 3 times 16. 16 for the atomic mass of oxygen. You have 3 there because you have 3 atoms of oxygen. So this is how you calculate what? The molar mass of calcium carbonate. And this is equal to, let's get our calculator. So you have 12.375 over, you have 40 plus 12 plus 3 times 16. I hope you can see that. And this is equal to, you have this 0.124 mole of calcium carbonate. If you can write the answer to 3 decimal places, so it will be 0.124 mole of calcium carbonate. Okay, now that you have the moles of calcium carbonate, you can now calculate the moles of carbon dioxide. You can see the ratio is 1 to 1. Can you see there is an invisible one there and there is an invisible one there? So you are going to use stoichiometry to calculate the number of moles of carbon dioxide. Okay, so the ratio of calcium carbonate and carbon dioxide is 1 to 1. Therefore, the number of moles of carbon dioxide is also equal to this one, 0.124 mole of carbon dioxide, because the ratio is 1 to 1. You can now calculate the volume, okay, using this formula. So it's equal to, you have N, which is this one, the number of moles, times Vm, which is the molar gas volume. It's given there. This one, can you see that? So V is equal to, let's use our calculator again. You have 0.124 times 24,000. This is equal to 2976. Okay, 2976 cubic centimeter. You can see the units are cubic centimeter because mole times per mole will cancel and the unit will remain cubic centimeter. Okay, or you can say it is equal to 2.976 cubic decimeter when you divide by 1000. So x is equal to this or this. 5.5. How will the reaction rate change if 15 grams of a pure sample of calcium carbonate react with the sample hydrochloric acid solution? Choose from increased, decreased, or remains the same. So how will it change now that you have 15 grams of a pure sample? No more 15 grams of an impure sample. Obviously, you can see the reaction rate will increase. You'll have more mass or more particles of calcium carbonate. So the reaction rate will increase. So you are going to choose increases. 5.5 increases. Now 5.6, use the collision theory to explain the answer to question 5.5. Why do you say that the reaction rate will increase now that you have 15 grams of a pure sample instead of 15 grams of an impure sample? Obviously, you can see when you have a pure sample now, you are going to have more particles of calcium carbonate with correct orientation, and this will lead to effective collision per unit time. So 5.6, you are going to have more calcium carbonate particles with correct orientation, and this will lead to more effective collision per unit time. Okay, we have used the collision theory to explain why the reaction rate will increase when you have now a pure sample of 15 grams of calcium carbonate. Okay, this is all from question 5 from November 2021 on rate of reaction. If you find some value in this video, don't forget to put your comment, your likes, and subscribe to the channel if you haven't subscribed. If this is not the first time to this channel, it is always nice to see you back again. Okay, as for now, we are done. You can see down below is my name and the email address at which you can contact us if you have any question or anything that you would like to let us know. Feel free to use the email address down below.